And a quick review on variation statements. So we have a couple different versions of variation. So if we have the statement y varies directly as x, now another way you could say that is y is proportional instead of varies directly. If y varies directly as x, we say that y is equal to some multiple of x. So y is equal to kx. And k here, just for reference, we call that the constant of proportionality. So constant of proportionality. Okay. And if another way we could modify that statement is if it varies directly as the blank power of x, that would just be having an exponent on x. Okay, first type of variation. Second type is inverse variation. So if we say y varies inversely as x, or is inversely proportional to x, that means that y is equal to k divided by x. Okay, because as we'd increase one, the other one would, as we increase, say, x, y would decrease. If they vary jointly, that means we have a product. So if z varies jointly as x and y, that means z is proportional to x and y, x times y, or z is equal to some constant of proportionality times x and y. And then jointly would just be, or jointly as the blank power of x would just mean you'd have an exponent on each of those. Okay. So a quick example that uses variation, and this, we will come back to this problem kind of frequently throughout the course. But if we talk about the ideal gas law, can be described as pressure varying jointly as the number of moles and temperature and varying inversely as volume. Okay, so first thing, in a problem context where you're not given variables is to define them. So I'm going to say P is equal to pressure. I'm going to say, let's see, the next thing that comes through is moles. N, I'm going to say, is the number of moles. T is temperature. And the last thing is volume. So V, capital V, is volume. Okay, so now translating this statement into mathematics. So it's saying the ideal gas law can be described as, and let's go through and highlight some things, varying jointly as, and I need to, okay, so that'll be the first thing. Joint variation means I have a product, so I need this and temperature, okay? So those are the two things being multiplied together. And then varies inversely as volume, okay? Let's write this out mathematically now. So pressure varies jointly, meaning I have some constant times number of moles, which I said was n, and I'm using k sub 1 here for the first constant, n times t, okay, and varying inversely, okay, so now in this context, and refers to multiplication, varies inversely, so that's k sub 2 divided by v, okay, and really the k's are just another constant, so I could rewrite this as k n t over v. Okay, and if you happen to check this out, this k is actually equal to, they use the variable r, and I forget what the exact number is. I think it's 8.314 or something. But this is a mathematical form of the ideal gas law that you can describe using variation. Okay, so just a quick review on variation statements.